Welcome to the first video of the year. Yay! So exciting. All right. So, right off the bat, just want to let you know that we are reviewing the rules of exponents. This and this is tomorrow. Okay, so I shortened it a little bit, so we're only dealing with the rules of exponents today. But this is just the beginning of the operations on functions unit, and the exponents are a 2-day objective. Okay, so today we have to remember the parts of a power. So this thing right here is a power, and the power has two parts. It has the x here, which is considered the base, and 2, which is your exponent. And altogether, that's called a power. Okay? So if you're looking at this one right here, we want to state the base. What's the base and what's the exponent? I find it easier to identify the exponent first. I probably should switch those around, but whatevs. So if you look at 2 to the x, what is the exponent? So right here, what is the exponent? Well, the exponent is x. What is the base going to that exponent? Well, that's the 2. So now for this one right here, what is the exponent? Okay, hopefully you notice that the exponent is 5. What is the base on that exponent? Now this is an important concept here. You have to understand that that 5 is only on the x. This is a multiplication problem, so it's 5 times x squared. So that, x to the 5th, my bad. So that 5 here is just kind of on its own. All right, after you do x to the 5th, then you're going to multiply by 5. So x is the base. Now, technically, this 5 right here does have two parts also. Technically, its exponent is 1, and the base is 5. So there are two powers in this particular problem. All right, and then this one right here, this last one, what is the exponent? Well, the exponent is -5. And what is the base? And these parentheses, they're like a warm hug. Okay, they're inclusive. They take care of everything that's inside of it is connected. So everything here, this whole thing is considered the base because of those parentheses. Okay, so this -5 is going to the everything inside those parentheses. So it's important you understand the concepts of that power. So we have 3 rules. 3 basic rules, and then tomorrow we have 2 sub-rules kind of thing that you just have to grasp. And what we have here is the 3 rules of exponents. The first one is this one. When you multiply bases, you add the exponents. So for example, if you have x squared times x cubed, that's x to the 5th, okay? And it's because x squared is x times x. And x cubed is 3x's. That's what the exponents mean. They just multiply times themselves. So then if you look at it all together, that is x to the 5th. So that's the concept. Okay, so down here we have an example. -2 and 3 are still numbers. Okay, just don't, they're bases, yes, but they are just numbers in this case because they do not have exponents on them other than 1. So you can just multiply these numbers. So you multiply numbers normal. Let's not get crazier here. And then you add the exponents on like bases. So I'm multiplying the bases. So I generally do this one piece at a time, though it is one multiplication problem. You're not distributing or anything, you're just multiplying. So it's x squared times x to the 4th. Well, there's 2 there and there's 4 there, so that would be x to the 6th. And this is y here, and 3 of them here. So remember, this is y times y cubed. So there's 4 of them. So you have to remember that there is a 1 on that. I don't like that green. So that's it. That was the answer to that one. When you divide, you subtract the exponents. And that's because if we have x to the 5th over x to the 3rd, that's like 1, 2, 3, 4, 5 over 1, 2, 3. They cancel out, and we're just left with 2 on the top. So 5 minus 3 is 2. So you normally, when you're dividing, you divide the numbers. So 14 and 2, we're going to divide those normal because they're still numbers. And you subtract the exponents. So 6 minus 6 is 0. So I have 0 x's. So that's gone. Okay, and then just y to the third. There's nothing on the bottom there to subtract, so it just stays. Done. You can put it over 1 if that's your desire, but it means the same thing. Power to a power. So what that means is we know that this thing right here is the whole thing is being raised to the 4th power. When you raise it to a power, you multiply the exponents. Right? So this is like x squared to the 3rd power. This is going to be power to power, you multiply the exponents. So it just means that you have x squared 3 times. And if we remember here, 1, 2, 1, 2, 1, 2, look at that, magic, x to the 6th. So we shorten it so that we don't have to do that rule 100 times. Power to power, we multiply our exponents. So you just have to make sure everything has an exponent to begin with. So anything that doesn't have an exponent, I give one so I don't mess up and, accidentally multiply the wrong thing. So you only can multiply exponents. And there we go. That's the answer. Now, 3 to the 4th, generally we do the math there. 3 to the 4th is 81, x to the 20th, y to the 4th. Okay, whenever you get confused, remember these examples. They tend to help you out a little. So then we have slightly more complicated examples. All right, but all you have to remember is that when you multiply bases, so here are the bases, I can see them. I'm multiplying bases, so I add the exponents. So I'm adding 2x plus 3 and 4x minus 7. I add these together and I get 6x minus 4. But I have to keep the base, so x to the 6x minus 4. Because I added them together and that's what they turned out to be. Next, I divide here. So remember this line here means division. So when I divide, I subtract exponents. So it's 2c plus 4 minus c minus 2. So it's minus the whole thing. Just remember that. So I always do a keep, change this to addition, but then change the signs of both of these. So it becomes minus c and a positive 2. So it's a keep, change when we do subtraction. Keep the first thing the same, change subtraction to addition, and change the sign of the second piece. And then we just add the normal things together. So that's c plus 6, and we have an x for the base. So those were just the exponents I was adding. Got to keep that base. Right, power to power and division. You can do anything you want first, but here I can't really divide because the bases aren't the same. So I simply make sure, so I have this power outside of the parentheses. I just make sure everything has an exponent. So 4 has an exponent, x has an exponent, and I simply distribute that to each piece. So it's 4 squared, x to the 6a, over 3 squared, y to the 8c. Nothing's the same, so you can do the math for these. So it's 16 x to the 6a, 9 y to the 8c, and that's about all you can do. That was exciting. All right, now here we have a base. That's a 3. So the exponents on these are 4 and a. So here you just have to be a little careful. The bases don't change. Okay, pretend like they're x's if it confuses you, but bases don't change. It's the exponents that change. Those aren't numbers now because since they have an exponent, they are a base. The moment they get an exponent, they are now a base. So we simply do, bases are the same, so we add the exponents. 4 plus a. Can't do anything to it, so it's 3 to the 4 plus a power. That's it. I can't do anything else. All right, here we go. So we have power to a power. Now, I should take care of the top first. because it has an exponent. We just still do follow the orders of operations. So I just make sure each one of these has an exponent. So it would be 2 to the 5th power, x to the 5th power. Nothing happens on the bottom yet, but there we are. But we should make sure when we're dealing with powers of exponents and things like that, we want to make sure that everything has an exponent so I don't accidentally mess up other parts of it and cross over and create new math. Okay, so we have 2 to the 5th and 2 to the 1st. These bases are the same, so I subtract the exponent. So 5 minus 1 is 4, so it's 2 to the 4th. Whenever I do the subtraction, the answer is always on top. Answer on top. When you're dividing and you subtract, the answer is always the top of the fraction. And so this is x to the 5th, x to the 3rd. 5 minus 3 is 2. All right, I do have numbers 2 to the 4th, so then I can do that math there. 16, I believe. 16x squared over 1, or it's just 16. And then the last one, I'm dividing the numbers. I'm dividing these powers, so I subtract the exponent. So it's 3 minus a, well, that's about it. Remember, the base stays the same. If you can't handle the 10 being there, think of it as an x. Okay, so some of you always have problems with this kind of issue. So if I think of this as, let's just do any sort of example. I'm not going to use 10 because I just did. So let's use like 2 to the 5th over 2 squared. So remember, this is 2, 5 of them, and 2 on the bottom. So I'm going to have 2 to the 3rd power on the top, 5 minus, but it's still 2 to the 3rd power. Okay, so I'm not canceling out those 2's because they're a base. The moment they become a base, they're not a coefficient. I can't just divide them. All right, so have a wonderful day. See you tomorrow.